Emostel.
Hi, you're welcome to this video. Now in this tutorial, we are just going to be discussing so much about some very important rules that you must bear in mind as a physics practical student when it comes to dealing with graphs. Very important rules. Please make sure you don't forget any of these rules, both for the theory application and then also for the practical application. All right, so let's dive into those rules. So number one is the 3/4 rule. You see, this is it. If this is your graph book, all right, let's assume this is the page of your graph book. If you divide this page into 4 equal parts, okay, you don't have to divide it physically, but you know there is a way you can get that by counting the number of boxes and then dividing it into 4. Okay, the basic thing is just that every of your graph, your physics graph, by the time you finish performing your experiment and taking down the records, okay, it is extremely important, very important that your physics graph should be magnified in such a way that it should contain at least 3/4 of it should cover at least 3/4 of your entire graph book. Some people will have their graph book like this, and then the graph they will draw will just be very tiny, maybe from here to here. It is not allowed. You look for a suitable scale, you choose a suitable scale that will enable your graph to cover at least 3/4 of the graph book. If it covers the full length of the graph book, no problem. But your graph must not be small. Half is not tolerated. Half of the graph book is not tolerated, 1/4 is not tolerated. The minimum is from 3/4 and above. Reason is that when your graph is large, is big enough, okay, it will enable you to be able to get a more accurate reading or deduction from the graph compared to when the graph is small. So when the graph is smaller in size, it increases the error, the error rate or the error possibility, the possibility of having errors, okay? So, but then you remove the errors with the size. The bigger the size of the graph, the lesser the tendency of having errors. I think the more accurate your graph will tend to be, okay? So please take note of that, the 3/4 rule. Then number 2 is the axis label rule. You see, when you have your graph, it is very important that you label the axis of your graph. Okay, so, okay, maybe you're plotting your graph, you have this axis and then you have this axis, this is the origin, okay? Maybe this is your graph page, okay? Very important that your graph must be labeled. It is very important that it must be labeled. So you can have this place, maybe you're plotting a graph of velocity against time, for instance. So just say V in what? Meter per seconds, and then time T in seconds, okay? So your axis must be well labeled so that whoever is looking at your graph or is studying your graph will know exactly what you are doing. The person will know exactly what you're plotting against what, and then what you're trying to derive from the plotting. Do you understand it now? So you will keep someone lost if your graph is not well labeled, because the person will not really have an idea of what you are plotting against what, or of the two quantities that you are plotting on the graph, okay, or that is being represented by the graph. So that's for that. Number 3, the title rule. Hey, apart from the fact that you plot the graph, okay, and then you labeled the axis, it is also very extremely important. It's of utmost importance that you give the graph a title. So the title of the graph could be the graph of velocity V in meter per second against time t, in seconds. Very important. In fact, it is also good to indicate the scale of the graph. Like after your title, it is also good to indicate the scale of the graph. The scale of the graph is, you can choose that, okay, let every 2 centimeters on your graph. You know, those tick boxes, we have 2 types of graph like that. There are some kind of graph, the yellow, the orange colored graph. Every tick box is 2 centimeters in length. Okay, it's like 2 centimeters here, 2 centimeters here. The dimension of the tick box is 2 centimeters all around. Okay, but we have the green graph. The green one has its own is 1 centimeter. Okay, so that one, the graphs are like more tinier. Okay, the thick lines are tinier. Okay, so whichever graph that you're using, okay, is also very important to indicate the scale that you used, so that the person seeing what you represent can easily follow up with what you're doing, what you're representing. Okay, the person will say, okay, this person used 2 centimeters to represent 1 second on this axis, and then the person used 2 centimeters to represent 5 meters per second on the velocity axis. So, which means if you use 2 centimeters to represent 5 meters per second on the velocity axis, it means that every 2 centimeters represent 5 units on the v-axis. So this one will be like 5, another 5, 10, another 5, 15, plus another 5, 20, plus another 5, 25, and so on and so forth. Okay, so that is what it shows that, okay, you have used a scale of 5 centimeters to represent of 2 centimeters, every 2 centimeters, that is every thick line on the v-axis, which is the velocity axis, represents 5 meters per second. Okay, so that's that. Then if you can choose like, okay, on this one, let every 2 centimeters represent 1 second. So if every 2 centimeters represent 1 second, it means it will increment by 1. So this is 1, this is 2, 3, 4, 5, and so on and so forth. Then this will be -1, -2, and so forth. You understand that now? So the scale is good. It is very important to write the title of the graph and also followed by the scale that you applied on the graph. It is formal to do so. Okay? All right, so that's the title rule. This is the title of the graph of this against that. Okay, this one is the labeling of the axis. Okay, all right. Now, number 4, the double line or thick line prohibition. It is very prohibited for you to draw, those of you who don't know how to draw a straight line at once. Whenever you have your points, just place your ruler and then draw it once, and that's okay. It is prohibited in physics graph for you to have a graph that the line is very thick. You make sure your pencil is sharp enough, but not enough to tear the paper. All right? Otherwise, you will default the anti-piercing rule, which is number 6, rule number 6. We are going to get there. So your paper, your pencil should be sharp, but not too sharp to tear the paper. All right? But the sharpness is just to ensure that the line of your graph is not fat. It's not fat, so you sharpen it properly so that the line will be very thin and dark, thin and clear. Okay? So, all right, so thick lines is prohibited, double line is also prohibited, like this. It's prohibited. No, you don't do it in graph. Or maybe you draw the line, and then when you are trying to trace it again, then there came to be some kind of overlap. Okay, it's very prohibited. So you don't tolerate it. The line must be thin and straight and fine. So now number 5, the points and lines of best fits. Okay, there is something we call the points of best fits, the lines of best fits. Okay, so because of some kind of errors during experiments, which is like unavoidable. Okay, you will find it difficult to achieve maybe after an experiment, you have everything totally aligning. like all the points totally, after the experiment and you have made your table of values and then you plot a graph of one quantity against another quantity and then you got the points. Okay, when t squared is 5, x is m is 1 or 2, and then you merge the two places and you create a point. When t squared is this one is that, you merge the two places. It is very difficult for you to get a graph that we have totally correct points that follow each other, as in very straight. It is difficult for you to have such. Most likely, in your physics experiments, you are going to be having graphs which points are scattered, but not too scattered. They can be scattered, but they will be very closely related. All right? This is allowed. This happens. It happens very well. But the thing is just that you must try as much as possible in your physics experiments to ensure that you observe every bit of accuracy. You observe every detail of accuracy. It is very essential that you try as much as possible to follow the precautions carefully and you carry out the experiment carefully just to make sure that you have an accurate result. So if you have your accurate result, you have the tendency that the graph of that experiment, you will have the points. The points may not totally align, but they will be very close. Now, for you to now determine the points you will use to draw your line, you choose the one we call the points of best fit, the points that align the most. Look at, if you have 6 points, maybe you carried out the experiment 6 times to get 6 different values and all of that, and you plot the graph, okay? So, let's 1, 2, 3, 4, 5, 6. Okay, this one is like 6. Out of the 6, okay, look for the best 3 or the best 4, not the best 2. It shouldn't be less than half, okay? Out of the 6 points, look for the best 3, at least the best 3 line that's really fits properly, or the best 4 points that fit properly. So those are the points of best fit. So when you are able to locate those ones, connect them. Sometimes you may not have points aligning totally, but you will see, like you'll be able to draw a line that passes through all the points. Like in this one now, you see that I can easily draw, which I have a long ruler here. Okay, I can easily draw something like this. If I draw something like this, it is not bad. The line passed through all the scattered points, okay? And then you will see that you just make sure that it passes through, it has placed, even though it doesn't connect the 3 points directly or the 4 points directly, your target points must be close enough to the line. Because it's possible you have this one now, for instance, that is not so close to it. This one is not so close to it, but this is very close. This is like almost on top. This is like on top too, okay? And then if you draw your line like this, you are very good. You are very okay. All right? So the points of best fit are the best 3 points that align, or 4 points that align. Then the line that you draw connecting those points or passing through those points is called the line of best fit. Do you understand? So, because your line, the accuracy of your line is very essential, very important to the accuracy, to the correctness of your experiments. Imagine you are carrying out an experiment on the acceleration due to gravity and you did not get your points well properly. The result you might get at the end of the day might not be so close to the actual value of acceleration due to gravity. But if you carry out the experiment very well and you are careful enough and you are able to select the best lines or the best points of that align and you draw it very well, you have a high tendency that at the end of the day when you find the slope, you are going to get a value that is exactly equal to the agreed value of the acceleration to gravity or so close to it. All right? So that is that. As for that, it has to do with the law of practice though. So this is covered. Then the anti-piercing rule, which means your pencil must not pierce your graph book. It is forbidden. We don't like physics, we don't permit perforated graph books in physics. all right? So because that hole could even bring about error in measurements. It could even bring about wrong message, could pass the wrong message to some readers who may not know that it was a hole that was there, and they will just think, okay, that maybe it's also a point, or for any reason else anyway. So the slope triangle rule is the next one. Well, the slope triangle rule tells us that tiny slope triangle is not advised. If you want to be very sure of your value, of your physics experiment, all right, maybe if it is a maths graph, okay, you can use a tiny slope triangle as far as the 2 points, because that one, the graph is determined by an equation, an already made equation. But in physics graph, it wasn't an equation that determined it per se. You didn't use the equation. You performed an experiment and took readings. And it is the readings that you try to plot, the value of the reading that you plot on the graph. So that you cannot really you cannot compare to that of mathematics, whereby you follow an equation, you follow some given set of values, and then you plot the graph and all that. No, this one you experimented to get those set of values. And so there is tendency that the experiment is not so accurate, and there's tendency for human error, there's tendency for environmental error, and anything else. You understand this? So because of that, it is not advised to draw the small slope, because you have the tendency of getting a wrong value, okay? But you try as much as possible to make your slope triangle to be as big as possible, as big and as compact as possible at the same time. So don't let it be excessively big, but let it be moderately big. So we believe in physics that when you draw a good slope triangle, a big enough slope triangle, you have a higher tendency of getting an accurate result for the slope of the graph, okay? You have the tendency of getting at least close to the value of the expected value in that experiment. For instance, if you are plotting a graph, if you are doing the experiment of a simple pendulum, the expected value of the slope is like 0.04, so that you can be able to obtain a value close to 9.8 after your calculation. So for you to get as close as possible to the expected value, after making sure you get the line of best and the line of best fit, passing through the point of best fit, you draw a sufficiently big slope triangle that will represent the slope, or that will produce the slope. Then the next one is the no coordinates rule. Please, we don't allow you, this is not mathematics. In physics graph, you are not allowed to write the coordinates and say, okay, t is, maybe m is 2, y t squared is 10. You don't put the coordinate on your graph book. You may just put point P and point Q, and that will be all. But all those coordinate thing and the calculations and every other thing, you do it in the notes aspect of your graph. You know, every graph book, we have a notes attached to it. Like if you have a page as a graph book, a laboratory graph book, we always have a note following the graph page. So it's on top of that note that you may want to represent your coordinates, but not on the graph itself. So you don't put a coordinate on the graph itself and say, okay, x is 2, y is 10, and then x is, you don't do that, okay? IS is that indicates like this is point P, this is point Q. IS, like if at all. Then you now make this place to be like changing. Maybe you are plotting a graph of velocity against time. You say changing V in what? In meter per second. Then this one, changing T, okay, in seconds. This is the highest that you can do. So let them just know that the whole of this place is representing the change in value of the time, while from here to here represent the change in value of what? Or the velocity. But the coordinates should be written rather in your book. If at all you need to write them, it should be in the note side, not on the graph book. All right, then the next one is the clear erase rule, which means that anytime you made a mistake and then you want to erase, please erase clearly. So that erase is clearly in such a way that the former line you drew should not be competing with the actual line that you wish to represent. So some people will not erase it properly, so it will not be looking as if you have a double line for your graph, and it could be so confusing. And that is the reason why it is important that when you want to draw your graph, don't put all your hand on it in such a way that it will be too thick for you to erase thoroughly. But you know, if you just try to like draw the line normally without adding too much pressure on your pencil, if you made a mistake, okay, if you make a mistake along the line, it will be easy for you to erase because it will clean off easily compared to when you apply too much pressure on the pencil to draw the line, and then the line becomes too dark and then too difficult to erase. So please, any error you make on your graph book, make sure you erase the error completely. So, and then that is just that aspect. That there is something I didn't really remember to tell you on when we're talking about the graph of trying to find the value of acceleration due to gravity with a simple pendulum from inaccessible height. Exactly the way we have we could have an intercept on the horizontal axis. The way we add it for the graph of for that spiral spring experiment, we also have it too for the experiments of the inaccessible height. So the intercept on the horizontal axis represents the height of the room. If you apply the same method with which I derived the fact that the intercept on the horizontal axis for M determines the value for the effective mass of the spring. Okay, that's like 2 videos ago. All right, the same procedure you can also apply it to the graph of t squared against small h in the simple pendulum experiment for the pendulum hung at inaccessible height. So you just refer to the video and then check it out, and then you'll also be able to get it. I don't just want to start writing that now, but you can get it yourself. Just follow the same step and you get it. If you still have any problem with that, please contact me, and I'm going to I'll gladly attend to you and explain to you in detail. All right, so that marks the end of this particular video and also the end of all our discussions on graph. So from the next video, we'll be talking about a different topic entirely, which is measurements, okay? All right, so before I tell you that I will see you there, remember the 4 things. Learn, you understand, make sure you acquire understanding. Don't just learn by cramming, understand thoroughly, and then also you practice with what you understood, and then when you can do these 3 things, excellence is not far from you. See you in the next video. Bye.